Hello and welcome to this third video on metals aimed at National 4 and National 5 level. This one's going to be dealing with ores and extraction, or basically the question, where do metals come from? Hello and welcome to this third video in a series on metals aimed at National 4 and National 5 level. This one will deal with ores and extraction, or the question, where do metals come from? Now I'm going to assume you've seen the previous video in this series. I'm going to assume that you know that some metals are more reactive than others, and that we can list the metals in order of reactivity, usually putting the most reactive at the top and the least at the bottom. And this is known as the reactivity series. In another series of videos we'll also see it called the electrochemical series, which is basically the same but with one or two slight differences. But we'll worry about that another time. So the question is, where do metals come from? Well, let's consider our list of metals. Let's consider potassium right there at the top. If you take a little pile of potassium, drop a little bit of water on it, it's going to react violently and produce potassium hydroxide. But the point is, you are never going to find potassium as a metal in the ground. If there ever was any potassium in the ground, or if you put potassium metal in the ground, it's going to react with stuff around it. So you are never going to find potassium as a metal in the ground, only potassium compounds. And in fact, that applies to the vast majority of metals. All those, right the way down to copper, you will pretty much never find as metals in the ground. They would react with anything around them to form metal compounds. And even copper, only very, very, very occasionally will you find copper metal in the ground. These remaining metals, you do find simply as metals in the ground. So for example, that's a picture of a seam of gold in the rocks, in the ground. All you have to do is break the rocks off it in some way. But you can see that's gold metal shining there in the rocks. Now, metals that we find in the ground as metals are called native metals. But there aren't very many of them. Only the least reactive metals are found as native metals. The rest are found in rocks that we call ores. Ores are rocks that contain metal compounds. For example, bauxite. Now that might not look very interesting to you, but I'm seeing aeroplanes here because that rock, that bauxite, contains aluminium oxide. Now if we can break that aluminium oxide up into aluminium and oxygen, we can use the aluminium to make aeroplanes, among other things. So bauxite is an ore that contains aluminium compounds from which we can get aluminium. This is malachite, pretty blue-green colour. That contains copper carbonate, which we can break up to form copper. So we get copper from malachite by breaking up the copper compounds in malachite. One more, that's hematite. That's an ore of iron. That's why it's that rusty colour. It's basically iron oxide. And from that, we can extract iron. So we extract metals from ores. But how? Well, that depends on how reactive the metal is. You see, there's a basic rule. The more reactive a metal is, the harder it is to extract from its ores, the harder it is to break up its compounds. Now, why should that be? Well, let's consider an experiment we looked at in the previous video. In the last video, we talked about reacting metals with oxygen. So let's suppose we react copper with oxygen and magnesium with oxygen. Now, when copper burns, when copper reacts with oxygen, it burns with a dull, quite boring red glow. That's because it's only releasing a small amount of energy when it burns. So, when copper reacts with oxygen, forms copper oxide and releases a small amount of energy. On the other hand, when magnesium burns, it burns with a brilliant white light and releases a lot of energy. So when magnesium burns, a lot of energy is released to form magnesium oxide. In a sense, that's what reactivity means. It's the amount of energy released when metals react with other things. So, when you form copper oxide, you get a little amount of energy released. When you form magnesium oxide, you get much more energy released. But to extract the metal, you've got to kind of do that backward. You've got to turn the copper oxide back into copper and oxygen again. That means you've got to put the same amount of energy back. So you only have to put a little amount of energy into copper oxide to turn it into copper and oxygen. On the other hand, to turn magnesium oxide back into magnesium and oxygen, you've got to put a lot more energy back, like that. So, the more reactive a metal is, the more energy you have to put in to breaking up its compounds and extracting it from its ore. So, how do we actually do it? Well, for your least reactive metals, these down here, these are usually found native. You don't have to extract them at all. Silver, just occasionally, you might find as a compound in an ore, but even then, all you would have to do is heat it to extract the silver. So, for these least reactive metals, extraction is either not necessary or dead easy. You just heat it. For the metals in the middle of this table, what you do is you heat the ore with carbon. Basically, the carbon takes oxygen away from the metal. This process is called smelting, and we'll be looking at it in more detail in the next video. For your most reactive metals, there are a variety of ways of extracting these metals, but a common method is electrolysis, where you melt the ore and pass electricity through it. Again, we'll be looking at that in more detail in the next video. Okay, to sum up, your very unreactive metals are found as metals in the ground. That's your silver, gold, platinum. These are found as metals in the ground, and we call them native metals. Other metals are found combined with other elements as compounds in rocks. And we call these rocks ores. And what we want to do is extract the metal from its ore. We want to break up the metal compound to get the metal on its own. But the more reactive a metal is, the harder it is to extract from its ore. So we looked at a variety of techniques for doing that. For the least reactive metals, and basically I'm talking silver and mercury here, you can just heat the ore. If you heat mercury ore, you get mercury coming out. If you heat silver ore, you get silver produced. It's fairly straightforward. For your moderately reactive metals, metals up to zinc in the reactivity series, then you heat the ore with carbon. This is a process called smelting, and basically the carbon takes oxygen away from the metal. For your most reactive metals, anything more reactive than zinc, a common method is to electrolyse the ore. You melt the ore and pass electricity through it. As I say, we'll be looking at smelting and electrolysis in more detail with specific examples in the next video. But for the moment, that's all. Thanks for watching and goodbye.